Okie dokie. Hi guys, this is going to be a bit of an experiment, but today we're going to do 2.5 infinite limits. Alright, first of all, bear with me because I'm writing with a mouse, but this says graph f of x equals 3 over x minus 2. I don't know if yours looks like that nonsense also, so there we go. Alright, this is a review from pre-calculus, but we're also going to include limits when we talk about it. So, first of all, what can x not be? That's always what you want to think about first. And that would be x cannot be 2 because that makes the denominator equal 0. So we know immediately that we have a vertical asymptote of x equals 2. Don't forget, it's a line, so you need to put x equals 2. Alright, so we're going to put a vertical line at x equals 2. Change that to red. Okay. Oops. Whatever. Alright, so we have the vertical line at x equals 2. Oh, look at that, it went right over top of it. Okay, and that's the vertical asymptote. Now we need to think about if it has any horizontal asymptotes. Now, we learned some rules back in pre-calculus. That was like the exponent of the numerator and the exponent of the denominator, and if the numerator was less than the denominator, if it was equal to or greater than. So you are welcome to look those up, but now we're going to use, and memorize them again, but we're going to use calculus now to do that. So, let's think about the limit as x goes to 2. Oh, I'm sorry. Let's think about the limit as x goes, oh no, we haven't talked about infinite limits yet. So, yeah, let's talk about when as x goes to infinity, what this function is going to do. Now, we haven't talked about infinite limits yet, so we need to think about both our pre-calculus training and what we think it's going to do just by plugging in numbers that are larger and larger and larger. Okay, so let's think about numbers that are larger and larger and what happens to this whole value right here. Okay, so pick x equals 5. Let's just start with that, because we're going off to infinity. This is infinity for x's, yeah? And here's negative infinity, which we're also going to do and see if it has a horizontal asymptote. So you can have a horizontal asymptote to the right, and you can have a different one to the left, or because it's talking about out at infinity, all right? So let's find out what it does out at infinity. So let's just start with 5. When x equals 5, what do you get? You get 3/3, right? So you get 1. Alright, so when x is 2, 4, 5, we get 1. Okay? Alright, when x is, let's just go with 6. When x is 6, we get 3/4. Right? So when x is 6, we get 3/4. Alright, how about when x, so it looks like it's going down, but it could just keep on going down this way. I don't know. So how about when x is like 1,000? Alright, or let's just say 1,002. Then we get 3 over 1,000. Yeah? That is really, really, really close to 0, but still positive. So I'm going to say it's close to positive 0. In other words, from the top side of 0. So yeah, so I'm going to get a horizontal asymptote at 0. Now I got to check if it's going to approach it the other way. So I know that it's going to look like this. Okay? So let's put in 4 and see what we get. 4 minus 2 is 2, 3/2. So 1.5 would be like, right. 3/2. Right there. But I don't know, it's not lining up nicely, so I'm just gonna do this. Okay, that's good enough. Alright, Now let's do the limit as x goes to negative infinity. Right? Of 3 over x minus 2. All right. Pick a negative number. So, or let's pick 0. All right. First of all, just because I need to get my y-intercept anyway, so why not? So pick 0 and I get negative 3x. So that's 1, right? So 1.5 is right there. Okay. But it could go like this. It could not approach that at all. I don't know. All right. Now pick like a negative 1,000 or 998, I guess. Pick negative 998. What do you get? You get 3 over negative 1,000. All right. What's that really close to? Well, it's really close to negative 0. Right? And I know negative 0 doesn't make any sense, that 0 is neither positive or negative, but it does, when you really think about it, it means like it's almost 0, but it's still on the negative side. So I'm going to be almost 0, but still on the negative side. So that must mean that this function, this side of the function, looks like this. Okay? All right. Also, I could have figured out, like, so now from the picture, I'm going to ask you a couple of questions. So this is what horizontal asymptotes mean, is you take the limits as x goes to infinity, and if you get a value, then that is what the horizontal asymptote is. So the limit, there's only one horizontal asymptote, and it is y equals 0. Make sense? I hope so, because I can't hear you if you just said no. All right, so now let's answer a couple of questions about other limits. So just really quickly, what is the limit as x approaches 2? All right, so that's what I'm asking. Just to practice for our test. What's the limit as x approaches 2 of f of x? Okay? All right. Well, if you look at it, all right, you remember your little person and you're walking. All right, but on this side you're walking. All right, so the limit as x approaches 2 from the left, so this side, right, of f of x is what? So you can write it. It's negative infinity. All right? And then what about from the right? Oops. Just kidding. Try that again. Group it is what I meant to do. Okay. All right, so what about the limit as x approaches 2 from the right? So if you're walking from the right, you go to positive infinity. All right, so these two right here, they don't match, which means this one does not exist. Okay? Okay, let's do the next one. So first I want you to go ahead and identify the vertical asymptote and graph it. And these are just counting by ones. That's fine. Oh, I'm sorry, I should probably tell you what the function is, because I don't know if yours is messed up. Yours is all garbly gook or not. Alright, so f of x equals 1 over x plus 2 squared. Okay, so let's start with the vertical asymptote. Go ahead and write it. Okay, and graph it. Alright, so we got x equals negative 2. And there it is. Okay. Alright. Now, let's find out if there are any horizontal asymptotes. So, to do the horizontal asymptotes, it's a lot more work. The limit. But they were a lot more work in pre-cal too. You had to memorize those rules, which you can absolutely memorize. And I would suggest that maybe you go back and look them up at least. Alright. And, because that will help you know if you got your limit part right. Okay? Alright. So the limit as x goes to infinity of 1 over x plus 2 squared? All right, what is that? All right, so you just think of larger and larger and larger. So let's do -1. Okay, or let's just start with 0. When x is 0, I get a quarter. So 0, and I get a quarter. I'm just doing that because I want to graph it. Okay. All right, now when x is 1, I get a 9th. Smaller. When x is 2, I get a 16th. That's even smaller than a 9th. When x is a billion, I get a 1 over a billion squared. So I'm saying that it is 0 because 1 over a very, very large number is going to be 0. All right, so whenever you have a constant over infinity, you're going to get 0. All right, we're going to write that maybe on after this. We're going to write some little tricks to remember. Okay, so I get 0 for the positive side. So I know that I'm at least going to have horizontal asymptote here. Now we draw it both sides, but it doesn't mean that your graph has to approach it on both sides. I just know it's approaching it over here. So this is going to look like that so far. Okay, I don't know if I'm going up or down. So as you get closer and closer to -2 from the right, let's think about that. Okay, like -1, what do you get? You get 1 over 1, so you get 1, right? Oh, looks like it's going up, right? Okay, so there we go. Ooh, don't cross it. Oh, sorry, it's bad mouse drawing. Okay, now let's do the limit as x goes to -infinity of 1 over x plus 2 squared. Okay, well again, -infinity, so like -1 billion plus 2 is still pretty close to -1 billion. Then I'm going to square it, so that's really, really big number on the bottom. So 1 over an extremely large number on the bottom is going to be 0. Okay, so these don't have to match. You could have x goes to infinity and you get 0, and you go x goes to -infinity and you get 5, and you would just have 2 horizontal asymptotes, one at 0 and one at 5. Okay, but we only get 1 at y equals 0. Okay, and it approaches both ways. All right, so, and this looks like it's going to be from the positive side of 0 also, because this, when it squared it, we gave it a positive number and then 1 over it, so it's a very small positive. But let's just check. 1, 2, 3. Plug in -3, and you get -1 squared, which is 1, so 1 over 1 is 1. Yep. Okay, so that's what it looks like. Now, I would like for you to tell me, so just an aside again, just like this one was not part of the problem, it just had to graph it, I graphed it, that was it. Okay, I would like for you to tell me the limit of f of x as x goes to -2. So what's the limit as x goes to -2 of f of x? Again, I'm just asking because this is like something that would be on your test. Okay? Alright, so I'll give you a minute. You work it out. Okie doke. I don't know how long to give you when I can't see you writing. I hope you're writing. Are you writing? Karen? Right. Okay, so I'm going to infinity. Alright, it's because as I go from the right, I go to infinity, and as I go from the left, I go to infinity, so I go to infinity, which means there is no limit, but again, I'd like to see the infinity sign so that I know that you know what you're talking about. Okay, moving right along. The limit of a vertical asymptote will always be plus or minus infinity, or does not exist. And that makes sense because you got to approach it, right? That's what happens with vertical asymptotes is the graph approaches it but never touches it. So if it always is getting closer but never touching, it's got to shoot off to positive infinity or negative infinity. And the only reason it would not exist is because one side goes to positive and one side goes to negative. Okay, So it's not doesn't not exist because there's like a hole there or something like that. The limit doesn't exist because the two sides don't match. You're still going to get positive infinity for one side and negative infinity for the other side. Okay, determine all vertical asymptotes of the graph of each function. So it's not saying graph, it's just saying find the vertical asymptotes. This is 1 over 2 times x plus 1. All right, well that's easy. Where does the denominator equal 0? Add x equals negative 1. Okay. All right, next one. Let's go with, let's see, this one over here. It's got x squared plus 1, is what it says, over x squared minus 1. Okay, don't be fooled here. Nothing cancels. Do not cancel these x squareds, all right? This is subtraction. These are two terms. They're not multiples. You can only cancel multiplication with division, not addition. All right, so, but you can factor that into x plus 1 times x minus 1. So your vertical asymptotes are x equals 1 and x equals negative 1, which you could also write as just x equals plus or minus 1 if you wanted to. That would be fine. All right, cotangent. Jaron, I bet you remember this one. All right, so let's see here. Cotangent. Now remember, tangent goes pi over 2 and negative pi over 2. Cotangent goes 0 to pi. And it goes this way. Okay, and then the next one is, so over here, let's see, like that. That's negative pi. Alright, so pi, and then the next one would be 2 pi, and so on and so forth. So the vertical asymptotes are at x equals 0, pi, so negative pi, so negative 2 pi, dot, 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 so negative 2 pi, negative pi, 0, because these are a length of pi, so that's how I know the next one was going to be 2 pi. By the way, pi, 2 pi, dot, dot, dot. So, oh, let's see if we can find a pattern for it. So how do you, what are these? They're not just odd numbers, they're not just even numbers, so it's just integers, right? So that's an easy one. So x equals k pi, where k is in z. Alright, so there you go. That's the pattern one. Alright, last one of this kind. Let's do x squared plus 2x minus 8 over x squared minus 4. Alright, so what do you notice immediately? Well, I know this one factors, so I bet this one's going to factor with an x plus 2 or an x minus 2, but let's see. So this is x plus 4 x minus 2, right? That gives me negative 8, that's good, yep, over x plus 4, sorry, that's not right at all, x plus 2, x minus 2. Okay, sweet, so those cancel. Alright, so there's a hole at 2, and then remember, plug in 2, so you get 6/4, which is 3 halves. Okay, that's not a vertical asymptote. I asked for vertical asymptotes. So the only vertical asymptote is at x equals negative 2. Okay? Alright, find each limit. I get, let's see, this is x squared minus 3x over x minus 1. Okay? Alright, so we can factor this, but it's not going to help anything, I don't think. No, because it's just x times x minus 3, which doesn't cancel with x minus 1. Alright, and I want the limit as x goes to 1 from the left. Okay, so we can try to graph it and see what that does. So let me just factor it anyway, just because I can't handle that not being factored when it does. Okay. So I know there's going to be a vertical asymptote at 1. Right? And then I know when x is 0, I get 0. And when x is 3, I also get 0. Right? Okay. And let's see. Let's try when x is 2. I get 2 times negative 1 over 1. So I get negative 2. Right? So it looks like it's doing something like that. Right? Okay. Because I know I have to approach this. Alright? Now, what about, but it's from the, oh, I'm sorry, this is from the left is what that is. X approaches 1 from the left. I don't know if you can see that on yours. Okay, so we still got to come from this way, so let's just pick something between 0 and 1, like a half. So I get a half times, what, negative 2 and a half, or let's just do 6. So 1 minus 6 is negative 5 halves over negative a half. Good, so those are going to cancel, and that's going to cancel. So I get 5 halves. So 1 half, 2 halves, 3 halves, 4 halves, 5 halves. So it's going to look like that. Oops, there's a half. Okay, so it must go that way. So I would say it's positive infinity. Good. Okay, and then from the right is this one, and if you just look at the graph, it's negative infinity. So the that is the same function here. So the entire limit actually doesn't exist. So the limit as x goes to 1 of x squared minus 3x over x minus 1 actually does not exist. That would be maybe a part C on the test. Okie doke. Let's get on to the limits. That's a mess. Alright, so this is the limit. Ooh, that's awful. What happened with that? Oh, it's because I accidentally did that weird one there. Okay, let's try that again. Alright, the limit as x goes to 0 of 1 plus 1 over x squared. Alright? So, let's see. Let's split this up. So it's saying that you can split up the, okay, so it's saying that you can split up the limit. So the limit as x goes to 0 of 1 plus the limit as x goes to 0 of 1 over x squared. Now I know that you're saying, wait, where does it say that? And it says it right here where we didn't fill it in. All it was saying here is that you can do sum or difference, you can do product, and you can do quotient, as long as the denominator doesn't equal 0, obviously. But you can treat limits separately or together as one function. Alright? So here, so we can split up the limit across 1 and 1 over x squared because this is a sum. You can also do it across multiplication, subtraction, division, as long as the denominator doesn't equal 0, so on and so forth. Okay, so now we know that this is 1, because this is just a continuous function. Plug it in, you still get 1. Alright, now plug in 0 here. That's not a continuous function, so we're going to have to think about the picture of it. And if you think about it, as x gets closer and closer to 0, you're going to get infinity. right? Okay, so that's infinity. If you don't remember the picture of that, that is this. Good? Alright. So, and 1 plus a very large number is going to be a very large number, so it's infinity. Okie doke. The next one says, what does it say? It says the limit as x goes to 1 from the left. So, let me just rewrite it because that's messy. Limit as x goes to 1 from the left of 1 plus, oh, sorry, that's not right. I'm copying the first problem. Okay, the limit as x goes to 1 from the left of x squared plus 1 over the cotangent of pi x. Ew, that looks terrible. Okay. For cotangent of pi x, when x is 1, alright, let's think about it. So, cotangent of pi x, when x is 1, cotangent is, what? So cotangent is, well, this is cosine of pi x over sine of pi x. So really, cotangent's going to be 0 when x is 1, right? So there's a vertical asymptote. Cotangent is going to not exist when x is 1, right? Because if you plug in 1 for x, you get cosine of pi over sine of pi, right? And what's the cosine of pi? That's over here at negative 1, 0. So the cosine is, what am I doing? Sorry. Alright, so at x equals 1, then the cotangent of pi is negative 1 over 0. So it does not exist. So the cotangent has a vertical asymptote at x equals 1. So this means that there's a vertical asymptote at x equals 1. Which means this is either going to come out to be positive infinity or negative infinity because you're coming from the left, right? So I know I'm going to get infinity, I just don't know if it's positive or negative. Remember on the other page where I said that the only reason you get does not exist is because the left and the right don't match each other. So I know since this is just from the left that I'm either going to get positive or negative infinity. Okay, so we're just going to try some numbers to the left of 1 and see what we get. Alright, now I'm going to pick some numbers to the left of 1. So let's start with like a half. Alright, then we get the cotangent of pi over 2, right? Which is cotangent of pi over 2, right there. So that's at 0, 1, right? So 0 over 1, which is 0. Okay? Then let's try a fourth, because that's closer. Let's see, to the left. Oh, no, so I'm going, actually got smaller, but... Alright, let's see here. So this is code, but I'm trying things that I know are on the unit circle. So I'm just going to have to see what happens. Alright, so let's see. This is actually closer to 0, right? But alright, so let's see here. What do I get? I get cotangent of pi over 4, which is cosine of pi over 4 and sine of pi over 4. They equal, so you get 1, right? Alright, let's try x equals to 6, because that's all I can do. That's the only numbers I know that are going to come out as pi over something that are remotely close to 1. So that's why I'm choosing this. And then I'm going to see if I can see a pattern. So I'm actually going this way, because this is approaching 1, if you look that way. Alright, so cotangent of pi over 6. Cosine is root 3 over 2, and sine, remember pi over 6 is right here. So it's the long x one, the short y. So root 3 over 2 over half, which just gives you root 3. Okay. So let's see here. Okay, but you'll notice that because we're talking about cotangent, it could be circular, so I could cross through some more values. So it looks like I'm approaching 0, but I know that there's a vertical asymptote at x equals 1 for cotangent, right? And I'm sorry, I don't know that this approaches infinity. I didn't mean that. I meant that right here. This, I know, has to go to either positive or negative. This right here has to go to plus or minus infinity. Don't know which one, but because there's a vertical asymptote at x equals 1 for cotangent of pi over x, not the whole thing. Cotangent of pi over x has to go to plus or minus infinity because I know there's a vertical asymptote at x equals 1. Okay? All right, so back to this. So I don't know, it looks like it's going to 0, but that's because I haven't tested anything else on the other side of a half towards 1. So like x equals, right, what's on the half? So 3/4, we could do that, because that's also something we could do. So that would be the cotangent of 3 pi over 4, and I'm sorry if you have to squish this in here. So 1 pi over 4, 2 pi over 4, 3 pi over 4 is going to be what? So that's negative over positive, so negative 1. Okay, so see, there we go. It's going back around. As I get closer to 1, right, I'm getting farther again from 0. So it goes close to 0 and then farther away from 0. But I know, and that's because if you think of the picture of a cotangent, it goes like a cubic, so it's getting close and then farther. So I know that it's going toward negative infinity. But here's the kicker. It really doesn't matter which one it was going towards, because I care about this entire function here, all right? All I need to do was, so these right here were not necessary, just a little bit of cotangent review, because once I know that there's a vertical asymptote at x equals 1, I know that this denominator here is going to be infinity or negative infinity, right? Okay, so let's put a little star here, and now let's come down here and read it. So that means that this is equal to the limit as x goes to 1 from the left of x squared plus 1, right, over the limit, right, because this is a quotient, the limit as x goes to 1 from the left of cotangent of pi x. So we can divide up the quotients just like we could the sums. Even though this one looks weird, you can't do this with logarithms or anything, but you can do it with limits, okay? And the whole reason I needed to figure out that this went to positive or negative infinity is that I just need to make sure it wasn't going to 0. If this went to 0, remember you can't split them up, but you can't get over 0. All right, but it's not equal to 0. Even if it was going to 0, that's one thing, but you can't have it equaling 0. So I couldn't just like plug it straight in, okay? All right, but I know that this is infinity, so all I gotta do is figure out the limit of this. We'll just plug this in. This is a continuous function, so it doesn't matter if it's from the left or from the right. Just plug it in. And what do you get? You get 2, right? So that means that I get 2. So what's going on in my head, I can't write that because you can't write like 2 over infinity. Just like here, this should have been in my head also. Okay. All right, so 2 over infinity. Really what that means is 2 over this is going larger and larger and larger and larger, and I don't know if it's plus or minus. Doesn't matter. Okay, but it's still getting bigger and bigger in value and magnitude. So 2 over a really big, big, big number is going to be 0. Okay? So a constant over a really large number is 0. Now let's go back through and say what was important in this, because it was a lot of talking going on. And I can't see your faces, so I don't know if you're okay. All right. So first, I took the cotangent of pi over x, and I decided that it had a vertical asymptote at 1. Okay? And since it has a vertical asymptote at 1, then I know, because of the rules of vertical asymptotes, that my function has to either go to infinity or negative infinity. Okay? Now, Once I know that, I can be done with it. All right, so I'm just going to say, okay, so this is 2 over infinity, and 2 over really large in magnitude, doesn't have to be positive or negative, doesn't matter about that, 2 over a very large negative, or 2 over a very large positive number is going to end up being 0. Okay? Alright, and that's what I was thinking there. Okay. Another one. Alright, the limit as x approaches 0 from the right of 3 natural log of x. Okay, so I'm going to say, well, first of all, this is just a constant multiple, so I can pull it out. So this is 3 times the limit as x goes to 0 from the right of the natural log of x. Okay? And eventually we're going to get to where we don't even pull it out. We just think of this and then multiply it by 3. Okay? But that's what we're doing. Okay, so now we need to think about the natural log of x. Alright? And we graphed this earlier, and I told you, you need to know how to graph this. There's a vertical asymptote, which is why we're going to 0 from the right, because we can't go to 0 from the left. Alright, and as you walk along towards 0 from the right, you go to negative infinity. So what I'm thinking in my head is 3 times negative infinity. Alright? And 3 times a negative large number is going to be a negative large number. Now let me warn you, infinity divided by, let me write it down so you understand what I'm saying. Okay, so a new page. A constant over infinity is going to be 0. It doesn't matter if it's positive or negative infinity, because it still is like 2 over negative 2 billion is still very, very, very small. It's just on the negative side of 0. Whereas this one's going to be on the positive side of 0. Okay? Infinity over a constant, plus or minus again, is going to be infinity. Alright? Again, because it's making it slower, but it's not stopping. Okay? And then, a constant over something going to 0, it's not 0, it's going to 0, alright, is going to be infinity, or negative, I don't know which one, okay, you have to decide that. Alright, so it's going to 0, it's not actually 0, these are things you can't actually write, these are just things that are going on in our head, okay? Alright, there is no infinity over infinity. They don't cancel. You don't know if it's infinity. You can't do anything with that. There's special things. And 0 over 0, like going to 0, you don't know who's getting there faster, so you can't do anything with that. They don't cancel. They don't make 1. They don't make 0. They don't make infinity. Sometimes they'll make a number. Sometimes they'll make 0. Sometimes they'll make infinity. Okay, so you can't mess with those. But these constants mixed in with infinities or zeros, you can absolutely do. And 0 over constant 0, but yeah, I think I need to write that. Okay? Alright, so that concludes our 2.5. And let me just see. Yeah. Okay, so that concludes 2.5. I highly recommend that you do your homework, and I will see you on Monday at lunch. Have fun at the college fair. Make good choices.